Welcome to part 2 of learning about two-dimensional arrays. Does that make this like our golden episode or something? I bet it does. Previously, we learned about two-dimensional arrays of data and how they're structured in rows and columns. We also talked about how to use indexes as a kind of coordinate pair to visualize and locate data within a data set of rows and columns. In this video, we're going to be putting that knowledge to work for us by building out a program that's going to help us with our grocery shopping. This program is going to be a little more involved than others that we've done so far, but I'm sure that you can do it. You know how I know that? Because even though I don't know you personally, if you're watching this, then you're clearly a person who's invested in their own success, and that is freaking sweet. Taking responsibility for yourself is an incredibly powerful skill for all areas of life. So, as we go through this today, remember, I believe in you and your ability to do this. It's worth it. You're worth it. Let's do it. All right, here we are in Visual Studio with our program structure set up, including our string library. In this video, we're going to build a program that will let us run some metrics on our grocery list example from the last video. So here we can see that we're going to use two arrays that are running in parallel. First, we have a one-dimensional array for the names of our grocery items, and then a two-dimensional array that stores the price and quantity for each of the items from our one-dimensional array. We're going to use this data to calculate the average price that we're paying per item. So let's get back to Visual Studio and get started with declaring our arrays. Before we declare our arrays, let's first declare our size variable. All right, great. Now we can go ahead and start with our first array, which is the grocery items array. Now, this array has 5 elements, but instead of putting the number 5 here like this, let's go ahead and use our size variable. And now we can initialize this with our grocery items. Excellent. Next, let's go ahead and declare our 2D items detail array. Now, the dimensions for this array needs to be 5 rows for the 5 items, right? And then 2 columns to represent the price and the quantity. Now, we could just put 5 and 2 here into our brackets, or maybe we could do like size and size 2, but instead I'm going to show you guys a little trick that I like to use. So right now we're using our size variable to represent the 5 rows in our array. So why don't we just call it rows? And then at that point, why don't we just kind of extend this a little further and create another one to represent our columns? This will be way easier to keep track of than something arbitrary like size 1 and size 2. Gotta love those well-named variables, right? So now we can use these here in our array declaration. Perfect, and now we can initialize this with its values. Now before we go on, just to refresh your memory, each one of these curly bracket kind of subsets is representative of a row in our array. And then the first value within that subset is the very first column, then we've got a comma to separate them, and then our second column. So again, each one of these is a row, and then the first value is the first column, second value is the second column, and it would be so on and so forth. Okay, now that we've got our arrays declared, it's time to start working on our logic. For this program, we need to print out the grocery list with the item name, price, and quantity, and then give the average price per item. We know from working with 1D arrays that we're going to want to use the for loop to iterate through each element in the array. So let's go ahead and knock that out. Now, up until this point, we've always used I, but because this is going to handle our rows, and we have our nice little row constant up here, I'm going to make this R, and we're going to use rows right there. Perfect. When our program's completed, we want our output to look like this. So the name of our grocery item, the price, and the quantity. And then at the end, we're going to give the total number of items and the average price per item. So with this in mind, let's go ahead and add our cout statement right here for our grocery items array. And let's go ahead and run this just to make sure that we're moving forward on the right foot. Okay, great. So here's all the items for our 1D array. Next, we need to display the price and quantity. So, how are we going to do this? So right now, we've got a single for loop that we're using to iterate through our 1D array. We're using R as both our iterator and as our array index. Since R starts at 0 and increases by 1 each time our loop runs, that's working great for us because it corresponds perfectly with the indexes of the rows in our array. What we need to do next in our program is to incorporate our 2D array into this logic, something that will allow us to iterate through our columns. So let's go ahead and take a stab at it. For our row index, we know that we want to use R because that's what we made it for, right? But now what do we want to put for our column index? If we put 0, we'd be printing out our price column of our 2D array. If we put 1, we'd be running into the same problem, but we'd only be printing the quantity column. We need something that's going to increment. So what if we put R there? What would that look like? Our loop would start with R at 0, right here. And then it would increase to 1, which takes our coordinates to 1, 1 over here. Next, R would increment to 2, which would take us over here. Okay, that's not going to work for us because we don't even have a column index 2. Rewind. But now what do we want to put for our column index? Well, if we put R, we would end up moving outside the range of our array. Instead of moving in that diagonal direction, what we want is something that goes like this. Something that could iterate through the columns while something else handles iterating through our loops. Wait, that's it? Eureka! We need a second for loop to handle iterating through our columns. And since we've got our column variable, we can go ahead and use that as our iterator. So now let's go ahead and go through this. R is going to go ahead and start at 0. Right here. And it's going to display our first grocery item and then move into our nested for loop, which is going to start at 0, 0. And then it's going to increment C to 1, which will take us over to our next column. Then we're going to go ahead and exit our nested for loop. C is going to reset to 0. R is going to increment to 1. And this means that we're starting our second row here, but we go back to the first column in our 2D array. And then we'll just continue through like this until we finish going all the way through. All right. Does that make sense? So our outer loop is going to serve for our row iterator, and our inner nested loop is going to serve for our column iterator. This dual for loop approach is the best way for handling 2D arrays. Even if we didn't have this grocery items array, we would still use the same logical setup for items detail because we need to iterate through the columns. So now that we've got that figured out, let's go ahead and get back to work. Okay, so now that we know we need a second for loop here to iterate through the columns in our two-dimensional array, let's go ahead and add that in. And again, since this is going to manage our columns, I'm going to use C and our column constant. Now we can put our C out here to display the values from our 2D array. and R for rows, and C for columns. Okay, great. Let's go ahead and run this and check our work. Okay, so this is looking good. We've got our items, our price, and our quantity, but I think we can clean this display up a little bit. Since we want to match this to the output that we saw earlier, we need a $sign here in front of the price, and then an X to indicate the quantity associated with that item, and then each of these items needs to be on its own row. So let's go ahead and hop back over to our code and get that worked out. Okay. The easiest thing to start with is going to be putting each item on its own line. So if we look at our code here, we know that this outer for loop is going to manage rows, and this inner for loop manages the columns. So if we want to create a new line on each row, where would we put that? Since this outer loop is the one managing our rows, it's within the scope of this for loop that we want to put anything row related. So we want to make sure that we're outside the scope of our column for loop and only applying to this outer loop. So let's go ahead and put a new line command right there. Okay, now let's take a deeper look at our inner for loop here. So as we saw earlier, what's happening is this is iterating through. C is 0, which is that first column, so the price, and it's going to display that, and then we're going to have a space. C is going to increment to 1, and then it is going to display the quantity. So basically, if C is equal to 0, then we're going to be referencing the price, and if C is equal to 1, we're going to be referencing the quantity. So when you say it like that, and it comes to our display, we need a $sign if we're referencing the price, and we need an X when we're referencing the quantity. So why don't we just use a nice if-else statement? So again here, if C is equal to 0, then we're referencing the price. So our cout statement is going to be our $sign, and then we'll call that first column here. And we don't want to hard code the column because again, we're only here if C is equal to 0, so it's automatically pulling what we need. Otherwise, if C is equal to 1, then we're referencing the quantity. So here's where we would place our X to indicate how many of that item we need. Okay, so let's go ahead and run this baby and see how we're looking. Awesome. Okay, so this is great. So we've got each item on its own line. We've got our $sign there to indicate the price times 5. So this is telling us we need 5 quantity of potatoes, and so on and so forth. So the next thing that we need to add is our logic here to display the total number of items and the average price per item. Okay, now before we go off programming willy-nilly to determine our average price per item, let's go ahead and take a look at the data set here and figure out how we're going to calculate that average price. So as I'm sure you know, an average price is going to be the total price of the entire purchase divided by the number of items purchased. So let's go ahead and figure a couple of those things out. First, we can go ahead and get the total number of items purchased by adding all of these together. So I'm just going to use a little Excel formula here for this, which I love. Big pro tip, guys, use Excel to do a lot of the formulas here. All right, so we know that we should be seeing 19 items total. Now, can we just add all this up like we just did here? Can we just sum it here, 805, and then divide that by 19? Well, no, we can't, because while potatoes might be 79 cents, and that is contributing to this price here, we bought 5 potatoes. So what we kind of need here is a subtotal for each of these purchases, and then we're going to go ahead and add all of that up. So let's get rid of this and go ahead and write out a formula. What we're going to do is we're going to take the price times the quantity purchased, and that's going to give us kind of our subtotal for that item. And then if we extend this all the way down for the rest of the items, there we go. So we can see easily now that we would have broke that original 805, even just here on carrots. All right, so now we can total this up. All right, great. So we should be expecting that our total purchase is going to cost $23.51, and we're going to take that and divide it by 19, which will give us the average price of $1.23. So we can go ahead and round this out in our program. So we should be expecting this, and this matches the sample output that we saw earlier. All right, great. Back to Visual Studio. Okay, so now that we know what we have to do, let's figure out how we're going to do it. But let's start with declaring the variables that we're going to need for our accumulator, our item counter, and for our average price. And again, counters, accumulators, they all should be initialized to 0 right off the bat. Okay, and then this will hold our average price. Now that we've got our variables, let's determine where in our program we need to put them. So let's go ahead and start with our item counter. So we're going to be just counting up all the items as we go through. Now we know that our inner for loop is going to manage our 2D array columns, and we kind of already have this little section of code here that only applies to that second column, so the quantity of items. So this might also be a good place to put our counter, because the scope of this else statement is only referencing the item column. So let's go ahead and put our counter right here. Item counter, and then again, this is the shorthand for adding to itself. And then what we want to add to the counter is whatever that quantity value is that we're currently on within our loops iteration. Okay, so every time this hits and we get to that second column with the quantity, it's going to take that number and add it to our counter. Okay, now that we've got the quantity taken care of, you might be thinking, oh, well, isn't that perfect? We have this other if statement that manages the price, so we can just put our accumulator for the price right here. Well, that's fair enough, but actually, if we go back to our test data, remember, we want to get kind of the subtotal per item, because if we just added all these prices up in that if statement, then we would be getting an inaccurate number. What we actually need is to go row by row and take the price of that item that we're on for that row and multiply it by the quantity. So since this is being calculated out per row, we're actually going to work within the scope of our outer loop, because that's managing our rows. So right down here, okay, and again, we're outside of our inner loop, but still within the scope of our outer loop. This is where we're going to accumulate our price. So we put our accumulator, and then again, our nice little shorthand here for adding to itself. And what we want to add here is our item details, the first row, 0, index 0, and that's going to represent the price, times the values in the second column. So we've got index 1 here. Okay, so this statement right here is essentially this formula from our spreadsheet. So it's taking the first column and multiplying it by the value in the second column. Okay? And finally, now we're ready to calculate our average, because we'll have our total number of items, we'll have the total cost for the whole transaction, and so now we can put our formula for average price. But we don't want to do that within the scope of our for loop, because we don't need to be doing it every single time, right? We want to calculate it when all is said and done. So we're going to make sure that we're outside of the scope here, and we're going to do average price equals whatever our total price of the whole transaction was, our accumulator, divided by the number of items that we purchased. Excellent. So now let's go ahead and give ourselves a little cout statement here to check our work. Okay, so we're going to show the user the average price for your, and then this will be the total number of items, is, and then we'll display the average price, and we used our set precision fixed here to make sure that it rounds out to those 2 digits. All right, let's go ahead and run this. All right, fantastic. So here we've got our arrays being printed, and then the average price for our 19 items is $1.24. And if we take a look at our test data, okay, 19 items and $1.24, if we were to round this up, that matches our test data perfectly. Fantastic, guys. Great job today. Great work today, everyone. I'm so proud of you for doing this with me, and I hope that you had fun rolling your sleeves up and getting some hands-on experience with 2D arrays. Remember, if you ever get stuck when working with arrays, writing out a table and visualizing your data can really help you get over those humps. And don't be afraid to make the little hump marks on your data table. Seriously, visualizing is so helpful. Again, way to stick it out. Thanks so much for watching, and we'll see you next time.